This is the Unknown Powders Identification Lab, which goes with Lesson 1 in your Friendly Chemistry course. In this lab, your students will practice making a series of observations on several unknown powders that you will provide for them. They'll record their data on data sheets, and then at the end of the lab, you'll have time to discuss and make hypotheses as to what they think the identity of these powders are. Let's take a look first at the data sheet which you will use to conduct this lab. In your student's book, they'll have several copies of these data tables. They'll need one data table for each powder that you provide for them. We'll talk about the powders here in just a minute. On the data sheet, they'll have a place to put their name and then an unknown powder identification number or letter. What you'll do beforehand is collect a set of powders, which are obviously known to you but unknown to your students, and you'll place them in containers and give them a label. I've gone A through D here, and depending upon how many powders you get, that's how many of these small containers that you'll use for the unknown powders. When the student first gets their powder, they'll first take a look at it. And on the column here it says, when I first looked at this powder, it looked like. And they'll go straight down here. They'll make a visual observation, they'll smell it, they'll feel it between their fingers, they'll take it, put it close to their ears to see if it makes any sounds, and they'll give it a taste. They'll just take a little, lick their finger and put a little dab on their finger and then touch their tongue with it. Okay? This last observation they make here brings up a very important point, and that's that the powders that you choose for this lab should all be safe, something that it would not harm one of your students. Let's take a look at some possible powders, then we'll come back to the data table here. Ideas for powders that you might consider using include table salt, baking powder, and baking soda, garlic salt, white flour, bleached flour, and then we have a sample here of some whole wheat flour, granulated white sugar. Powdered sugar is another good white powder to use. And then we have a container here of cornstarch. There are other examples of powders you might use found in your lab guide, your teacher edition, the pages for this lab. Okay, so as many of these different powders as you choose to use, you'll need these cups to put samples in for your students. Let's take a look back at our data table now. So when your students first get their powder, they're going to make these observations using their senses. And then the next column says, when I added drops of water, and they'll go right down the sheet here. They add a few drops of water to it so it looks like, it smells like, it feels like, if it makes any sounds. Okay, and then they won't taste it any longer after they add water to it. The only tasting is done is when they have the dry powder. So they're going to begin testing their unknown powders with water, then they're going to add vinegar to it, and then they're going to add drops of an iodine solution. So what you'll need to do beforehand is prepare these testing solutions for them. Now, I've labeled some containers here that will hold those three testing solutions. We have the water, we have the vinegar, and then we have the iodine solution. The water ideally should be distilled water, but you can certainly use just plain tap water. The vinegar, it's a good idea just to use white vinegar, because some of the powders you use may cause the, if you add vinegar, a colored substance to it, then their perception of the color may be slightly altered. So just use some white distilled vinegar. And then to prepare the iodine solution, what you can do is go to a local drugstore or a pharmacy, and even some grocery stores carry it, and find tincture of iodine. It's usually in the first aid section of the drugstore. Tincture of iodine now is a concentrated form of iodine, and you'll only need a few drops of this into water. So what we'll do here now is I have some water, and I'm just going to make our testing solution of our water here. Okay, the vinegar we would fill. I want to show you what the iodine solution should look like. We're just going to put some water here. Your goal is to make a test solution of iodine that just resembles iced tea, just a light brown color. Now, one thing you'll want to do is caution your students that iodine does stain. It stains fingers, it stains clothes, and it is poisonous. And so what you'll do is just pour some into the water, and you just want a light brown color like this. This is just a light tea color of the iodine solution, which is really all you really need there. Okay, so these are going to be the test solutions that your students will then draw upon when they begin getting the powders. Now, you'll have beforehand taken and put samples of each of your white powders into these cups, and so your students will then have access to these. And again, on their data table, there's a place here at the top. It says unknown powder ID number or letter. You can number those if you want. I just had already gone ahead and put letters on these, so that's where they'll put the A or number 1 or whichever, however you want to indicate those powder identifications. Again, they should not know what these powders are. Now, some students may take a look and say, I know what that is, or I know what that is, but tell them just, we're making observations, and then we'll talk about identities later on. So, because you don't want to contaminate your samples of your powders, what you'll have your students do then, and there's different ways to go about this. We found that just using cupcake liners, these waxed cupcake liners, work pretty nice for the students then to transfer some of the white powder sample into these at their desk or at their table. If you have lids from yogurt, plastic lids from yogurt cups, or like sour cream containers, those work nice. If you have access to lab equipment, petri dishes, especially the divided petri dishes, are handy for this, or even the lids from petri dishes work fine. Another alternative is just a piece of aluminum foil. Paper plates, styrofoam little paper plates work nice too. These cupcake liners are pretty darn cheap, and because you'll be using several with your students. So what your student then will do is, let's say for example this cup A, you've put white sugar into it, but your students won't know that. So you'll pass these around for your students to get a sample, and so they'll put a sample of the sugar into their testing tray here. We'll just call it the cupcake liner there. And then the first thing you'll want them to do is go ahead with a clean spoon is divide that sample into 3 parts. Okay, divide it into 3 little piles there inside the cupcake liner, which will enable them to have a sample for each of their testing solutions. We don't want to mix these with each other and the powder all at the same time, because we want to get results that show a result from each individual testing solution. So now that your student has their sample in their cupcake liner, they can go to their data sheet and just follow the data sheet. It says, when I first got my powder, it looked like. So that's where they make their visual observation. Then they sniff it. They can put a little between their fingers and see what it feels like. And you're wanting them to, the observations that they make, you don't want them to say, well, it feels like sugar, because that's already making a hypothesis. You want them to say, well, it feels gritty, or it feels grainy, or like in the case of cornstarch, it feels very smooth and soft. Then it sounded like, if you put some between your fingers or it's on the spoon, they stir it. If it makes any sort of sound, they need to record those observations. One thing about cornstarch is that actually if you take and put some between your fingers, it kind of can make a little squeaky sound. And then it tastes it like. And this is where the student will just lick their finger and touch the powder and put a little taste on their tongue to get a taste of it. And again, they need to use observation terms like, it tasted sweet, it tasted sour, it tasted bitter, it tasted like candy, it tasted anything that is an observational term, rather than saying it tastes like flour or it tastes like starch or something like that. Okay, so they've done their first series, and then so what they'll do next is move to their first testing solution. And if you've got several students doing this, it's probably a good idea to have these testing solutions, several sets of these per maybe 3 to 4 students to share on a table or desk area. And you don't want to contaminate these solutions with any of the powders either. And so droppers are handy if you don't have access to pipettes or droppers. Soda straws work really nice. And what you'll do is you'll have the powder in your thing, and you'll just put your finger over the end of the straw and go in and get a sample, and then you'll just drop it onto the powder there. And with a clean spoon, then, as you have your students stir it around and make observations of the powder. Okay, and then you'll go into another one of your samples you have there on your in your cupcake liner, is to just you'll have another clean straw in the iodine. You'll just go ahead and take the straw and drop in some more drops of the iodine, and then you'll do again with the vinegar. And then with each of those, your student will then record their observations on their data table. When I added drops of water, what happened to it? When I added drops of vinegar, and when I added the drops of the iodine. And then there's a fourth column here that, actually it's a fifth column, that the student can make any additional comments about their powder. Okay. Now, just some information for you. When you add vinegar is acetic acid here, and you're maybe aware of how vinegar and baking soda or baking powders react, and you'll get bubbles in those substances. So if you use baking powder or the baking soda, your student should expect, or you will expect to see bubbles form with the addition of the vinegar into that powder. Another bit of information that you may or may not be aware of is with the iodine. What we're mainly using the iodine here is an indicator of a starch. So any kind of powder that has a starch in it. And the example I referred to earlier was using the cornstarch, and cornstarch usually comes in the yellow. Argo is a brand of cornstarch. Any powder that has starch in it, the iodine will turn from being this tan or this tea color, this amber color, to a dark purpley bluish color, really dark purple, and that's an immediate color change there. And so the iodine, when I add drops of iodine, it will look, if it's a starch containing powder, right here, it looks blackish, bluish purple color change. And an interesting thing here, if you choose to use powdered sugar, if you choose powdered sugar as one of your unknown powders, sugar itself does not have a starch in it. There's no starch compounds in pure sugar. So granulated sugar or powdered sugar won't have any color change. You'll just see the same, that amber color of the iodine. However, in some packaging of powdered sugar, they do add cornstarch to it, and apparently they add cornstarch to prevent caking of the powdered sugar. So if you drop the iodine into the powdered sugar, you will get the positive starch test. You will see the bluish, blackish purple, and that can be kind of confusing, but it can also be an interesting topic to bring up about, maybe there's one or more powders in these powders I provided for you. So that can often bring a good bit of discussion into your lab situation. So once the student has made observations now, they filled out their whole chart here, and note down here at the bottom there is the warning, do not taste after any test solutions. The iodine is poisonous, so you don't want anyone putting any iodine in their mouth. Then at the bottom it says, based upon my observations, I hypothesize, which is I guess, that this substance is, and the students can put in here what they think it is, whether it's garlic salt, plain salt, whatever, flour, sucanat, any kind of powder that you've chosen to use, they guess here. Now, what I usually do with my students is I wait for everyone to complete their observations before any revealing is done as to what these powders are. And now granted, some students will work faster than others. Some really enjoy and take their time doing this. Some kind of feel like they need to be in a hurry to do it. So generally the way I manage that is I have another powder ready for those students who are ready to move on. And then I wait till the very end of class time to have the discussion over what the identity of these powders might be. Now, as you do get to that point of revealing what the powders are, instead of just saying, well, powder A is this, powder B is this, and close up the lab, the whole idea here is to talk about how we came to the conclusions of that powder A was indeed flour and B was sugar, and talk about what were those observations that were the key ones. What made you think, know for sure that powder A was flour and powder B was sugar? What was the definitive observation? And then when you look at other powders that look similar, how did you know that one was powder sugar and one was flour? They both kind of look the same when you start out, just from your visual observations there. And so work hard with your students to have them explicitly tell you what were the observations that were the ones that absolutely define for them the identity of that powder. And then in your teacher's guide, there's an example of a flow chart that's kind of a fun exercise to do with your students. And you might make copies of that and pass them out, and then have your students develop a similar flow chart, which will allow them to put their observations into the chart so that they can help you or someone else determine the identity of an unknown powder. An extension to this is have a powder ready for your students to take home with them. You can take one of the powders that you used in the lab. You can put together a mixture of powders. A fun challenge type powder to send home that I've done in the past is a mix, like a cake mix powder. You just buy a cake mix, or you can even pudding, instant puddings will have a combination of starches in them. They'll have flavorings and stuff in them. Some of those are kind of distractors, which make it even more interesting for your students. A self-rising flour that'll have the baking powder and flour in it. A pancake mix is another good powder. If you use potato flakes, instant potato flakes is another one that's just full of starch, but they definitely doesn't look like your cornstarch. So those are just some ideas for that powder that you could send home with your students for them to test at home, and then come back with a report of what the observations they made, and then what their hypotheses were about their unknown powder. You might send different powders home with different students, and that will make it more interesting too, so they all have something, a mystery, to come work on during the week while they're not in class with you. So this has been the Identification of Unknown Powders lab, which goes with lesson 1 in your friendly chemistry course. Make sure your students understand your expectations for behavior in the lab. Make sure they understand that you have to be safe in the lab. We have no horseplay allowed in the lab. They follow the instructions. If they want to do a test on their own outside your instructions, to make sure they check with you first before they do it, and then let them know what the consequences might be if they choose not to follow the instructions of the lab. And usually what I do there is, with those students, is they just sit along the side and observe the other students enjoying the lab, and that usually works to get them back in line with their conduct. So if you have any questions in carrying out your labs in the course, feel free to contact us. If you have ideas for improvements, we welcome hearing those, and we wish you the best with your students in your first lab.